Good day, students. Welcome to mathgoodserve.com. In this clip, we're going to be going over how to solve radical equations, the case where a radical is equal to a variable. All right, let's take a look at question number 1. The instructions are for us to solve and check the given radical equation algebraically and then solve graphically with a calculator. We're going to start out with our algebraic solution. We'll solve this equation algebraically first, and then we'll do a check and solve graphically. Okay, so let's take a look at the algebraic solution. Now, the goal to solve a radical equation, the first goal is to eliminate the radical. Okay, and then you solve the resulting equation. It could be a linear equation or a quadratic equation in the examples that we're going to be looking at. So for number 1, we have m equals to square root of 20 minus m. So the goal is to eliminate the radical. Now, what we're going to do here is we're going to simply square both sides of the equation. Okay, so you square the left side and the right side. Because the inverse of square root is square, in squaring the right side, we get rid of the radical. Okay, so we have m squared equals the square and the square root cancel out, so we're left with 20 minus m. Now this is a quadratic equation that's not in standard form. So the next step is to place this quadratic equation in standard form and solve by factoring or the quadratic formula. All right, so to put it in standard form just involves setting it equal to 0 with the terms in descending order of degrees. Okay, so I'm going to subtract 20 from both sides and add m to both sides. That will cause the right side to be equal to 0. Okay, so we have m squared plus m minus 20. Notice I wrote it in standard form, equals 0. Now let's try and solve this by factoring first. If this expression is prime, then we'll have to use the quadratic formula. Okay, we're going to be using the AC method. In this problem, A is 1, C is negative 20, so AC goes on top, negative 20, and B is 1. The two numbers that multiply to give you negative 20 and add to give you 1 are 5 and negative 4. Now, since A is equal to 1 in this problem, we can jump to the factored state. We do not need to factor by grouping here, so we can have m plus 5 times m minus 4 equals 0. Okay, now we're going to go ahead and set both sides, both factors, equal to 0 using the zero product property and solve them independently. The left equation, you subtract 5 from both sides, and you end up with the first possible solution, m equals negative 5. And on the right side, you add 4 to both sides, and you end up with the second possible solution, m equals positive 4. Anytime you're solving radical equations, you always want to check, because there are constraints on the domain. While you're squaring, extraneous solutions might be introduced. So in order to identify and neglect the extraneous solutions, we have to check both answers. All right, let's start by checking the smaller of the two results, m equals negative 5. We'll carry out our check by substituting negative 5 into the original problem. Okay, so the question we're going to be asking ourselves is negative 5, is it equal to the square root of 20 minus negative 5? How did I arrive with this equation right here? I simply substituted negative 5 into the original problem. So since we don't know if this is true or false, we will put a question mark on our equality symbol. So let's simplify the right side. Negative 5, is it equal to the square root of minus times minus is plus 20 plus 5? Is negative 5 equal to the square root of 25? Is negative 5 equal to the square root of 25, 5? Is that true? The answer is false. So that tells us that negative 5, this solution is extraneous. Okay? It doesn't satisfy the equation. So does that automatically mean that the second solution satisfies the equation? The answer is no. You must check both answers. Okay? So now we're going to check m equals 4. We're going to substitute it into the original equation by asking ourselves, is 4, is it equal to the square root of 20 minus 4? Is it? So we're going to proceed to simplify the left and right sides. Okay, the left side is already simplified, is 4. Using order of operations on the right side, we subtract 20 and 4, you get 16. Question is 4 equal to the square root of 16, 4? Absolutely. That's correct. So our answer, our solution based on our check, is m equals 4. Okay, now how do we solve this graphically? We're going to go ahead and use our graphing calculator to solve this same equation. Okay, so let's go ahead and do that. So we have our graphical solution. What we're going to be doing is we're going to simply graph both sides of the equation using our graphing function, and then use the intersect function of the calculator to determine the point of intersection. So our first step is to graph. We're going to graph in our graphing window. Y1 will be the left side of the equation, which is m, so this will be y1 will be equal to m. But since we're dealing with x and y, we're basically going to be looking at this independent variable here is going to be x, and this will be x also. So we're going to set y1 equal to this piece, and then we're going to set y2 equal to this piece. Okay, so y1 as a function of x would just be, instead of m, we're going to use x. And y2 as a function of x is going to be the square root of 20 minus, instead of m, we use x. Okay, so y1 we're going to put in x for m, and y2 we're going to put in the square root of 20 minus x. Okay, just think of m as the independent variable of the function. Okay, we do not have flexibility of specifying any variable that we desire when we're graphing functions. We just start with y and x. Okay, so we're going to press the y button, enter x for the left side of our radical equation m, and then for the right side, the square root of 20 minus x. Close that, enter, and then let's go ahead and zoom standard, zoom 6. That's the left side of the equation, and there goes the right side. We can clearly see that there's just one intersection here. So to see what the intersection is, we're going to use the calculate function. Let's write this down. So 2, we're going to now find the intersection. In this problem, we just have one intersection. So second function, calculate, option number 5, press 5 or scroll down. First curve is y equals x, press enter. Second curve is y equals the square root of 20 minus x, press enter. Guess, just move your cursor to a point close to the point of intersection you desire to determine. Press enter. You have 4, 4 for x and y. So what are we looking at here? We're looking at the x coordinate of the solution. Remember, we're looking for x. So our answer here is x equals 4. Okay, so that shows that our solution, remember we called mx, is m equals 4. there's no 5 here. Doesn't work. So there goes the answer to problem number 1. All right, let's take a look at problem number 2. We have to solve this equation. N equals the square root of negative 54 plus 15n. So we're going to follow the same instructions as we did in number 1. We're going to find the algebraic solution first and verify our answer algebraically. Then we'll look for the graphical solution using our graphing calculator. Okay, so we have n equals the square root of negative 54 plus 15n. The goal for solving radical equations is always to eliminate the radical wherever possible. Okay, so we have a radical isolated on the right side and a variable on the left side. So we will simply square both sides of our equation. On the left side, we'll have n square. On the right side, the square and square root are inverses, so they cancel each other out. You have negative 54 plus 15n. Now we have a quadratic equation. To solve it, we want to put it in standard form, set it equal to 0 with the terms in the descending order of degree. So we're going to add 54 to both sides and subtract 15n. Add 54, subtract 15n. When we apply that to both sides, that yields n squared minus 15n, because I want to put it in standard form, plus 54 equals 0. All right, so let's take a look at this solution we have here. This resulting quadratic equation could be factorable or prime. Let's try to see this factorable first. I'm going to use the AC method again to factor this. A is 1, C is 54. So AC is positive 54, and B is negative 15. So what two numbers multiply to yield positive 54 and adds to give you negative 15? Negative 9 and negative 6. That works perfectly. Now, since A is equal to 1, we can jump to the factored state. No need to factor by grouping here. So n minus 9 and n minus 6 equals 0. Using the zero product property of equality, we set both factors equal to 0. Now let's solve the first equation on the left. We add 9 to both sides, and we have n equals 9 as your first possible solution. Second equation, you add 6 to both sides, and you have n equals positive 6 as your second possible solution. Okay, so when you're solving radical equations, either these two answers could be solutions, one of them could be the solution, and the other extraneous, or both could be extraneous solutions. So how do we know if we have solutions here? We'll just simply do our check. Okay, so what we're going to be doing is we're going to be plugging in these answers into the original problem. N equals negative 54 plus 15n. Let's start with the smaller of the two. Let's try n equals 6. So the question is 6, plugging it into n on the left side, is it equal to the square root of negative 54 plus 15 times 6? Is it? All right, the left side is automatically 6. So is that equal to the square root of negative 54? 15 times 6 is 90. So is 6 equal to the square root of 90 minus 54 is 36. Is 6 equal to square root of 36 is 6. Is 6 equal to 6? Absolutely. which means that this is a solution, n equals 6. Now let's check to see if n equals 9 is also a solution or if it is extraneous. We're going to apply the same procedure. Is 9, is it equal to the square root of negative 54 plus 15 times 9? Is it? The left side is already 9, so is that equal to the square root of negative 54 plus, now 15 times 9 is 135. So is 9 equal to the square root of negative 54 plus 135 is 81. One more step. Is 9 equal to the square root of 81, 9? Absolutely. So this clearly shows that both of these two answers are our solutions. So we have two solutions here. So our solutions are n equals 6 and 9. Okay. Now let's proceed to our second method of solving this radical equation, which is the graphing method. Okay, so we're going to follow the same procedure as we did in number 1 to find our graphical solution. So we're just simply going to set y1 equal to the left side of the equation and y2 equal to the right side of the equation. All right, so let's go ahead and set it up right here. This left side right here is going to be y1, and this will be y2. Okay, so y1 as a function of x will be x. Okay, we're just going to call nx in order to plug it into the calculator. And then y2 as a function of x is going to be the square root of negative 54 plus 15. Instead of n, we're going to use x. All right, so steps are as follows. First of all, we're going to graph the two functions. In the y1 field, we're going to enter x. And then in the y2 field, we're going to enter the square root of negative, not minus, okay? So we have to be careful with that. Negative 54 plus 15x. All right, so enter these two in the calculator. Let's go ahead and do that. So we have this y1 is x, and then the second one is the square root of negative, don't use minus or else you're going to get a syntax error, plus 15x. Close that, enter. Our graph. Okay, so we have two intersections there, but it's kind of hard to see. Let's go ahead. I'm going to use a zoom box feature to zoom it to get a better view of the two intersections. So let's use the zoom box. So let's pick a point on the upper left corner of the intersection of the two lines. Make sure it's high enough. Enter. And then I'm going to scroll down so that the lower right corner of my window is to the right of the intersection of the 2 points. All right, bring it up a little bit. So the graphing calculator will just capture this portion of the entire graph. Okay, so let's press enter. There goes the line, and there goes your radical function. Okay, you see, you notice it goes up for a sec. It starts from the bottom, it goes up, and then comes right back down. All right, so let's go ahead and calculate our points of intersection. Second function, calculate. Option 5. First curve is y equals x. Second curve is y equals the square root of negative 54 plus 15x. Guess, now you're going to scroll your cursor to the first intersection. Since there are two here, so let's move it around there. That looks fair enough. Press enter. And you see that your first intersection is x equals 6. Okay, so we have x equals 6. And then let's take a look at the second intersection. We're going to follow the same procedure. Second function, calculate 5. First curve, y equals x. Second curve, y equals the square root of negative 54 plus 15x. Enter guess. Now we're going to move our cursor closer to the second point of intersection, which is somewhere around here. Enter. X equals 9. There goes our second point of intersection. So we clearly see that our solutions are not x, but n equals 6 and 9. We've been able to confirm these both graphically and algebraically. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. We'll appreciate your positive feedback. If you have any questions about the contents of this tutorial or any radical equation related question in general, just place your questions in the comment section below and we'll be glad to support you as soon as possible. More clips can be found on mathgotserved.com, and you can follow this link to gain access to more practice and also some worksheets on radical equations. Do not forget to subscribe to our channel for updates to other great tutorials such as this. Thanks again for watching and have a wonderful day.